All right, we're in another one of the French garages here. We're going to use both our snap-on meter and our inexpensive do-it-yourselfer type meter to test the electrical system on this 1999 Lexus. This has the Toyota 3-liter V6 that they used in so many of their products for a number of years. Let's begin with some basic checks. So we're hooked up to the 12-volt battery on the car. And I'll zoom in on the battery voltage there. And you can see it sitting at 12.721 volts. Now, remember, a fully charged battery should have 12.6. What's with that little extra to get us to 721? Well, that's what we call a surface charge. What we're going to do is we're going to turn the headlights on here for 30 seconds, zap off that surface charge, and then see where we're at. If I take a closer look at this battery has not been cleaned. You can see a little bit of wetness on the battery case, possibly from being overcharged. It's not uncommon to get that, especially in the hot weather here that we have in California. Okay, so we've taken off the surface charge. What you'll notice now is the battery's sitting a little bit below 12.6 volts. It's starting to recover. Now it's up to 12.5. So once you took off that surface charge, we definitely see that our voltage level is less, but you can also see the battery recovering. We are now ready to begin some of our tests. The first test we're going to do is to check our available voltage as we crank the engine over. To do so, we really want to prevent the engine from starting. To prevent the engine from starting, we're going to remove a fuse panel and take out the appropriate relay or EFI fuse so that we can crank the engine for 15 seconds without the engine starting up. We'll set the relay panel here on the battery so our labeling is easy to read. I've pulled out the EFI relay, that's this little black one right here, and that will prevent the electronic fuel injection, EFI, from functioning so that the engine won't receive any spark or any fuel, and it'll allow us to crank it over and have it not start up. This purple relay, incidentally shown here, this is the starter relay. If we remove this relay, the engine would not crank over. That's not what we want for this case. We want to crank the engine over for 15 seconds, and we want to keep an eye on this multimeter as we do it. So that was our available voltage. You can see the battery recovering. A good battery should snap right back up to 12.6. This went up to 12.4, 12.5 pretty quickly, and it looks like it's creeping back up there, which is fair. One thing to look at when you look at batteries is look at their date codes to figure out how old is this battery. Remember that batteries have a typical lifespan to them. This whole time we've only been hooked up to the negative and positive battery terminals. Within another 30 seconds, the battery is right back up to 12.6 volts. So I would say the battery has recovered nicely and it passed the available voltage test, which tells me two things: that this battery is capable of supplying the voltage and the current necessary to crank over the engine, and two, that the starting system doesn't have a real excessive current draw with it. The last thing I wanted to point out is that the car had a very nice cranking rhythm to it as we cranked it over. The last thing we would want to have looked at that voltage as we were cranking it and made sure that this meter stayed above 10.5 volts while we were cranking over the engine. Still connected to battery voltage with the snap-on 596 meter, what we're going to be looking at now is the alternator on this car. So what I like about this vehicle is the alternator is sitting here right on top. We're going to start this thing up, look at that same battery voltage as we run this engine to test out the charging system. Let me reset the camera. All right, we're going to go ahead and start this thing up. You can see with the engine running, we're sitting here at 14 volts. In fact, we're at 14.2. We should normally be between 13.8 and 14.8 when we rev up the engine with no load on it. So I'm going to hold up some revs by working the throttle with my hand. This vehicle is old enough that I can actually grab the throttle. It's not throttle by wire, so I can work the throttle from inside the engine compartment. Notice that the voltage regulator kept that voltage pretty steady at 14.2 volts no matter what the engine's RPM was. That voltage regulation looks good. The next tests I'm going to do are not really because I think that there's a problem with the alternator. In fact, at this point, I would say this thing checks out pretty good. I am going to turn the headlights on. I'm going to turn on as many accessories as I can to put a load on the electrical system. And when I do that, I am then going to see what the voltage drops down to. So we have this vehicle fully loaded down. You'll notice that voltage, even at idle, is still above 14 volts. Let me rev it up. It's staying very steady at 14 volts. Now you might be wondering what that noise is. With the air conditioning on, we're hearing a noisy AC compressor on this vehicle. So that would be something to note down for the customer or the vehicle owner. We have the headlights on, high beam, we have both seat heaters on, the rear window defroster, basically every electrical load that we could keep on, and this thing is still maintaining over 14 volts or over 13.8 volts in all that. Now you might notice, hey, the voltage is dropping down a little bit. As the vehicle warms up and the battery warms up, the voltage regulator is doing some temperature compensation and lowering the charge levels to compensate for a battery getting hotter. That's all normal on a vehicle with a charging system such as this. Okay, I've turned off the air conditioning, but I still have the headlights on to make sure that we are forcing the alternator to provide some charge out to run the headlights, some of the accessory circuits, and run this vehicle's electrical system. And you can see that our charge level has dropped with that temperature compensation, but we're still in that range of 13.8 to 14.8. And remember, we are also here at idle. At this point, what we're going to do is I'm going to zoom out and we're going to move our clip from on top of the battery. And this time, we're going to put this clip right on the back of the alternator. A little bit of squeezing allowed me to remove this plastic clip, get that out of the way, and now I can get my positive lead right on the back of the alternator. I've made this notation before, but remember, these alligator clips really do make your life a lot easier. At this point, with the negative lead on the negative terminal of the battery, and with the positive lead on the terminal right on the alternator, you can see what our voltage is. It's a little bit higher, which indicates there might be a possible voltage drop on that positive side. We'll measure that out in just a moment. To do that, I'm going to take the negative probe and instead of being on the negative battery terminal, I'm now going to place it on the positive battery terminal. You can see it connected right there on top of that terminal, like so. Now, what do I have for a voltage drop now? Well, I'm losing 1.58 volts. Let's see, just under 1.6 volts. Really, anything under a half a volt would be considered acceptable, so this voltage drop looks great. Not that there's any problems indicated with this alternator. I want to show you one additional test I would like to do. We're back at the battery. It might seem strange, but when the alternator is charging the battery, the charge lead off the alternator is the most positive point of the electrical circuit, and the case of the alternator is the most negative part of the circuit. So if I want to check voltage drop across the ground, I'm going to go to the negative battery terminal with my positive lead. With my negative meter lead, I'm going to go to the case of the alternator. So we're connected to the case of the alternator. The alternator is being forced to charge, and what you'll notice is I'm not dropping more than 0.02 volts across the ground. Let's see if it goes up at all when I change my negative connection. I'll move this connection point straight to the terminal itself in case there is any resistance in this connection. All right, so there you have it. We've done a variety of charging system tests and an available voltage test, which gave us a good indication of what was going on with the cranking system as well, using a variety of meters. What's acceptable on the negative side? I would like to see 0.1 volts or less. This is 0.02 volts. I'm really happy with that reading. And speaking about keeping things free, don't forget that while you're doing these voltage drop checks, you're asking the charging system to charge by having the headlights on, forcing some current to be coming out of this alternator and charging back that battery. Like I did here. One thing you'll notice is a good set of meter leads. Now you might be thinking, hey, that's great, but I don't want to be using a $500 meter. I have a $5 meter, like this one right here. Well, you notice present in the hook them up to the same spots. Well, that wraps up this test. And I have almost identical readings at 0.02 volts. There's a little bit of rounding in this meter. If I change its scale, remember that this cheaper meter is not auto-ranging, then you can see that it gets us back down to almost the same reading that we had with the other meeting. Definitely well within our means to pick up problems. The downside of these smaller meters, we don't have any of the record functions, and really what drives me crazy the most is that it has very short leads, so it does tax you as far as hooking up the meter correctly and reaching things that are large distances between each other. For this charging system on this car, though, this little multimeter works just fine. If there were charging system problems indicated with low voltage output, one of the things I would check is this drive belt here to make sure that it had the correct tension and that no belt slippage was occurring. This one looks good. All right, so there you have it. We've done a variety of charging system tests and an available voltage test, which gave us a good indication on what was going on with the cranking system as well. Using a variety of meters, a couple tips to finish up. I always recommend using these alligator clips to get a good secure connection and to keep your hands free. And speaking about keeping things free, make sure that you watch your meter leads. Do not let them get tied up in the belts or pulleys, and always try to keep them away from hot components such as your exhaust manifold so you don't melt the leads like I did here. One thing you will notice is a good set of meter leads will have white insulation underneath its colors of red and blacks to allow you to easily identify a damage present in the leads. Well, that wraps up this test. We'll see you in a future video. Keep learning.